Hey everyone, it's Krista, and here we are live again on another fun show. Sure, whatever. So, we're in the shop at my work, and we've got the fuel injector test bench. And I was going to talk a little bit about it. So, that's the test bench. You probably have seen those available from China, except for they'll have their own controls here. Well, all that broke. Controls here. Well, all that broke, and I ended up making my own controller that drives it. And you say, well, what's a controller? Well, it's where I program my own code that goes in it, and as soon as you turn it on, it runs my code. So it's not like where you load an operating system and then programs load. It just is the program. So controllers are like in gas pumps, like back when there were wristwatch digital, those are controllers. So embedded controllers is what got me excited in electrical engineering back in the 90s, before all this stuff was like so prevalent and cool, and before there was internet. And so a lot of times you hear people talk about an Arduino. And so they're typically, this is not actually an Arduino, but this is a thing that bolts to it. Or yeah, so typically you see some weird little blue card like this. They're like $30. And an Arduino has kind of a crap processor on it, but the whole point of the Arduino system was it was easy to program, and then you could do things like put a shield on it. That's, they call this add-on module a shield, and you could stack them and then take out different pins so you could use different functions. And so they'd make like labs, as it were, around a shield. And so like you could just take this other thing, put it on, and you could do networking or Bluetooth, control LEDs, run little servo motors. And that's great and all, except for those canned, contrived examples. They just, they never did it for me. I was like, why? Who cares? Like, so we'll talk a little bit about the different controllers, but pretty much I had this test bench, and its original control panel was pretty lame. It had a few built-in tests. So you had to use this card, and you'd press reset or drain, or you'd load your thing. And if you want to change a parameter, you got to hit the plus 180 times, stuff like that. Because you say, why? Well, I sell fuel injectors to the internet, to motorcycle shops for customers. And before I buying these to sell them, I wanted to learn how they work and which ways they go bad. And so I came up with these tests. And so we'll just run a test here real quick. And so I found 4 different tests that really characterize how a fuel injector behaves across its range of usage. Maybe I'll move over here. So this is the idle test, except for it's running really fast. So the pulses are really narrow, like 2.5 microseconds. I used an oscilloscope on my own motorcycle to see what its idle pulse widths were. And so I got some sample injectors from China. We have a great vendor. We have a great relationship with them. We would buy parts, and I tell them, hey, look, give me the best quality your factory can make. I'll pay a little more, and then they'll deliver that. They'll deliver you what you ask for. So I'm going to write these values down. This is the last of the 80 injectors we bought. So this first one is 38 cc's, 40, 40, 45. and 44. And so my controller has a little control panel, and it's kind of fancy. It's got buttons and stuff. And so it's kind of great because this one comes in its own case with its own buttons built in. And it's just awesome because it lets me interface with my equipment easy without having to build mounting points or other issues. And then we'll turn off the drain. And now we're set up for the mid test. So the mid test has a pulse width of 6.36 milliseconds. So 0.00636 seconds. And it'll do the waveforms this decides, and it'll blast it through to the injectors. Now I take these 4 tests and I enter their values into a database, and then I run a query via a web page that interfaces with the database. I run a query to group the injectors so that they're very similar pairs, because the motorcycles I sell to have 2 cylinders, they have 2 injectors. So obviously, looking at these results, you can see these 3 are kind of close and this one's a little higher. So you wouldn't want the lowest and the highest each, you'd want the 2 that look the closest to go with each other, not high and low. And so it does that across all 4 tests, which is pretty awesome, and like nobody does that. But it helps me prove I've got a great product before I sell it to customers. Okay, so it's 60, I think that's 63. Let's change that to a 3. And then 69, 66, 75, and then 74. So already on these tests, you can see that you wouldn't want to put the 3863 with the 4575, but you could put the 4575 with the 4474. These 2 are pretty well matched right now, and these 2 are pretty well matched right now. This kind of variation is a little bit wider than I was hoping for, but this batch isn't quite the quality we're used to, and I think it's because of all the COVID problems and supply issues. I mean, it affects everyone in the world, and so we've been buying this part number injector from this vendor in China for 10 years. And so I've had to rebuild this bench, this test bench, a couple times. So they've been really good before when I say, hey, I want matched injectors. They'd still have variation, and my tests would sort them pretty dramatically, but folks loved the results. And the price was fair because they're imported. And so this batch is more probably what you're going to pull off the shelf. And there have been some out-of-box failures, and that's something you're seeing on all the automotive channels lately is folks buy a new part from their favorite store and it doesn't work. Because it costs money to do 100% testing. We try to do 100% testing, so we're a very niche seller to a niche market. And I've built a reputation on caring and quality and really putting customers first. So that was the load test, which gets the closest to full duty cycle usage. And so here's the values. Now you see that this tube is not being tested in because it drains too slow. So it needs a new solenoid probably, or I'll take it apart again and see if there's trash in it. And I'll write down these values. So that one's just above 72, so we'll call him 73. And then 77, 67, well, let's call him 68. He's closer to 60. 82 and 81. Now in these tubes, you might not be able to tell, but there's like bolts, and this one has a nut. Well, I put the ballast in because I had a graduated cylinder, and I poured the same amount of fluid in each cylinder when it was not draining. And then I added ballast to take up room until they were all reading the same value. So the actual number isn't really relevant. It's the fact that they're compared to each other during my tests. So this next and final test on these injectors, this one is what I call the high test. It runs at 10,000 RPM or 12 milliseconds, and it has a 9.8 millisecond pulse width. That means the injector is on for almost 10 milliseconds, and then it only gets like 2 to recover for the next pulse. So this is a pretty mean test, and I do 1,400 counts or pulses. And so let's run this test. Now up here is a pressure gauge, and I use a pressure regulator from a Ducati motorcycle's fuel injection to run these tests. Like, I had to rebuild the whole thing, so I just used components that were similar to the customer's applications as possible. And then I'll write these values down, and then this is kind of like the conclusion of all the testing, and I can talk a little bit about the design of the parts and whatnot. So we have 71. We have 75. 66. 81. And 80. So now all of a sudden, these two don't look very compatible, do they? Because they vary by almost 10 up here. And so one of the cylinders is going to be a little richer, the other one's a little leaner. And sure, you can compensate that with programming, however, on like a dyno. But if you can start off with two that are nearly alike at each test, that's a better way. So obviously these two will be compatible. And then the database query will take all of the tests. So this is all 80 of them tested, and it'll then give us lots of matched pairs. Okay, that's done training. Turn that off. I think I'm gonna power down the whole bench so I can touch things safely. So now about the controllers. So an embedded controller can come on all different kinds of platforms, like Texas Instruments Launchpad products. Let's see. There we go. If I hide behind it, then it'll see it. I actually never did end up using this. Oh, those pins got bent. Another product, NXP. Wait, is this NXP? It says Cypress, so it might not be NXP, but I thought it was NXP. This guy here is like $4. So pretty incredible. So like manufacturers will sell chips to car makers, and then they will build a platform around it that you can use to figure out how you're going to program that chip to work with your application. Most of these goofball ones I bought were because they have a CAN bus, controller area network. I was hoping to build something that was sort of goofy to interface with CAN buses, and I never really did because life. This here is an Arduino Mini. And so it's more compact, but it has the same inputs and outputs along the edges. And if you Google these things and you download them, you'll see what their uses are. And I'll show you a little bit about that in a minute. Another one that's a product I have here at work that I use is a test bench. This is a wire tester. So we manufacture wires, and then we plug them into each end, and then this gizmo here will test them and tell you that the 4 wires are not touching each other and that they are okay. And so this little white card is an ESP32 Wi-Fi board, and it's like $18. And then I bought this other card off the Zon and, all the little connections. So the hard part's kind of the connections and figuring out what you want to do. And then like you have to build like on that thing where you touch it and how you interact with it. And that's where this cute little WIO terminal comes in. This is the box it comes in. Real cute thing. I thought it was an ESP, but it is not. It has some different kind of processor. And honestly, I don't care too much about the specifics of its processor because they give you the pinout of it, and that's what matters. Let's see. So it's kind of like a little bit goofy because this is one side, then that's the other, and like you would take this and put it over here. So this on the back of the WIO terminal is a 40-pin connector. And then I have this ribbon cables going to breakout so I could use those 40 pins. Something you see almost universally with these embedded things is this goofy pinout with all these colors. And the point is to let you know what the pin numbers are and then their names and functions. And so, can I see what I did? All right, so here, whatever BCM27 is, digital 0, analog 0, and PWM, that's pulse width mod pin 0, I have the signal coming out of this for the pulses. And so that's pin 13 on the connector, but within the software, these other things will have meaning. And that's kind of like a little bit of insider info you have to learn from examples that the company will provide with their box. And then let's see, move drain to 6. So I guess the drain, yeah, so previously I had the drain on this pin. For whatever reason, I wanted to move it up 1. And then move pump to 20. And the pump on and off is here. And so the part where things get kind of weird is like normally you see people just put an LED. Well, here we're driving a relay with this. And so this box only makes 3.3 volts. So you have to do research and digging, find examples and all this crap to then make it interface with what you're trying to accomplish. Well, the board on this died, the controller board down here. Let me see if I can move this around and show the guts. There's the guts. Can you see anything? No. All right, let's move you like that. And so I took the board, the whole thing apart. It had a metal box here for the fuel cell. And instead of fuel, we're using fuel injector test fluid, like this company that does fuel injection testing. They sell a fluid. And so it was leaking, and then up under here are solenoids and magnetic valves to drain each of the tubes. And there's also a transformer that makes some kind of crappy AC voltage. So I took that board out, and this is the right way? Yes, this is the right way. I took that board out and I held it up to a light, and then I took two pictures and inverted them and layered them, and then I created a drawing of the circuits. And then I analyzed what those components were and the pins. So you see there's two relays in the middle. One is for the pump and the other one is for the drain. And so you heard it click when I would run the drain. And so this gizmo here makes DC voltage, and it should be 12 because everything on this is 12 volts except for it puts out 20. Why? Well, probably just because China. I mean, there's no other reason why. So I then made notes about the different ins and outs. And so up here at the top, pins 1 and 2, oh, that's loose. Interesting. Oh, okay. So pins 1 and 2 go up to this connector, and then in the connector, they're all batched together. So when you send your sine wave in over here, it goes to these two heat sink components. And I wrote down its part number, and then I looked up what it does. And then you can kind of see I also changed the colors of the traces. So each different thing was not, like you could see this is all ground, and then this is the positive voltage. Giant capacitor, that's this guy. And like, this is why these things are here and why people get excited for this stuff. This gizmo here makes 12 volts that I use to trigger these 20 volts. And it's a little bit black magic how I make that work eventually. Another thing I had to do is I had a 12 volt fan here that was really grumpy. So I got a 24 volt fan. The pressure feed goes to the regulator and then on up to the injectors. Then it comes down to the return. And then all the things just drain into this bucket. So it's like, I know it's a lot of info to digest really quickly, but this is kind of the nerd stuff that excites me about electronics and what got me going. I was an electronics technician in the Navy, and we didn't get into the design or the why as much, but we often really had to get into some theory to help troubleshoot systems and fix things. And the more computerization there is now, like the harder things get to fix. So we had a good bit of nuts and bolts training. So yet another kind of controller thing is called a Raspberry Pi, and it has that 40-pin connector. And so this case would be for a Raspberry Pi 4 Model B. There's not a Raspberry Pi in here. But what I do have is I've got this ribbon cable going to my WIO terminal, and then I'm using these 4 pins, ground, and then white, blue, and purple. And so is there a way I can draw you in? Bear with me a little bit here. Okay, that's, I guess, all we're going to get. And then can I lower you and then point you at the thing? There we go. So I set up a test where I know I needed to turn a relay on and off. And then I bought these cute little cards. I've got some drawings here. So I found this on the Amazon, the cute little board. Oh, here we go. So this is the board I bought on Amazon, and I bought it because it was 3-volt compatible on its input. And so remember, our controller does 3 volts. And then I wasn't too sure how to wire this thing up. And so I just sat down with a bunch of wires and a 12-volt supply, and I had my WIO terminal, and I just tried to make a relay go click, click, using whatever it took to make that happen. I don't know why I added these other things in. I think all 3 are the same, actually. I think this was, it would work on my test setup, but not in here in the bench, because the other voltage, it needed to be thrown back. So I have, this is a gate in one direction, and this is the gate in the other direction, working backwards. So one pulls up and the other slams shut. But I rigged these just to try to make the dang thing work. And it did, and it made me so happy. So what makes this one different? I don't think any of these, I think all 3 of these are the same component. It's just that I laid them out differently in the drawing. And I played with different value resistors until I was able to make it behave the way I wanted. So there could be more discussion about that, like differently or later in life. But the hard part to me when playing with these things is physically, what do you do with your things to wire them up? So I use terminal blocks, and I always try to use terminal blocks to connect things with wires and end crimp terminals on each wire. It just makes it more reliable. And then otherwise I might solder things. So like I soldered, there's a resistor on the back of each one of these, and I soldered it to the pin, then bent that into the connector. So it like sort of looks simple, but it, I took each little piece of this project and I just wanted to prove each piece worked before going to the next one. Anyway, this is about my second most complicated project I've done for work regarding like test benches and things. And then I use thumb screws here instead of the screws that came from China because I had to take this apart like 100 times while trying to design it. So there's a little bit of how and why, and it's like, to me, this is exciting stuff because I was able to buy a relatively cheap product. That's the WIO Terminal. And what I love is that it came in its own little box, so you're not touching terminals. It's got a little joystick, and it has these 3 buttons on top you can play with, and the 40-pin output. It's got all kinds of different ways to talk to the thing, and then this is just for power USB. I use it to program it, but then once I'm done programming, this is just going to be dedicated for this test bench. And if I have another project, I'll replicate this technology for the other project and leave this dedicated so I'm not messing with the dots. But this is like cool stuff. Like I'm using programming and the embedded controller to make my customers happy with the products we sell and to increase reliability of our parts, and then also the fact that the injectors are matched in a way. I don't know if anyone else does that really, especially not across 4 different ranges. So like those 2 lower range tests are when you're at idle or going, say, through town at a steady speed. And then the 2 higher tests were for like if you're on a racetrack and you've got max load to max RPM. So that's where you're going to be shifting is around max load, and then you'll get up to max RPM, and then you're going to shift to the next gear. Now on a racetrack, you also care about those lower values matching, because if you go into a corner, you're going to trail throttle maybe almost all the way off or a little bit, and you still are going to want balance there so that you've got better control of the engine and it's smoother while you're braking in the braking zone. So it's pretty amazing stuff. I just like this kind of application just so excites me because it's real and it's not as contrived as so many examples you see. Another part of it too is like this is something gearheads can relate to. It's some of the things I would program for is like this. Well, we're checking quality of some pressure thing here and there, and it's just to make it better or whatever. I mean, this is like real stuff. Like rubber meets the road. So that's kind of cool. Anyway, thanks so much for watching. Whoever does see, you're welcome to ask questions, especially specific ones, and I'll try to answer them. What I love about when people share on well, anywhere on the internet is learning why. Why drives life. Once you learn why people make the choices they do, things make much more sense. And it's like, oh, of course. And you get to feel how they think. So that's the part about sharing that I enjoy, is helping someone else understand why. Anyway, that's it for today. I'm going to hit end stream. So thanks again for watching. If you liked this, please hit like and subscribe. Once I get to 50 subscribers, I know it's a huge number. We're breaking the internet all by ourselves. Once we get to that 50, then I can go live mobile, which excites me greatly. Then I'll be able to do more personal and interactive things. And then hit the notification bell, because I always welcome folks to say hi and keep me company while I'm bored at work trying to slog through tests. So thanks so much and have a good one.